Welcome to the deep dive. Our mission today is to cut through the complexity of modern AI research and really deliver a single profound insight tailor-made for you.
And we're tackling a problem that I think anyone who's used a powerful large language model, an LLM, has felt.
Oh, absolutely. It's that feeling of repetition. You ask it for something creative, something unique, and it serves up the same predictable, safe answer again and again.
It's this huge paradox, right? These models are billions of parameters, but they can feel so dull. And that's not an accident.
It's a feature, not a bug.
Yeah, in a way. It's a consequence of the very methods designed to make them helpful and safe. Things like RLHF, reinforcement learning from human feedback.
Right.
These processes, they unintentionally just crush the model's diversity, and researchers have a name for it: mode collapse.
Mode collapse, so the model gets stuck in a rut.
It gets trained to focus so intensely on a very narrow, statistically safe set of answers.
Okay, so let's unpack that with a direct, almost painful example. Imagine you're trying to generate some creative content, and you ask your fancy, state-of-the-art LLM, tell me 5 original jokes about coffee.
What mode collapse almost guarantees is that the model will just zero in on the single most popular, most agreeable, least offensive answer.
The mode.
The modal response, exactly. And it will just spit out variations of that one thing. So you'll get 5 versions of the same joke.
Something like.
Something like, why did the coffee file a police report? Because it got mugged.
And you'll just get that 5 times, maybe worded a little differently.
Yep. The core idea, the joke itself, is identical. And at that point, the model has completely failed. Its utility is gone.
And that is exactly where this deep dive is going. We've got research identifying the real, and I think surprising, cause of this repetition.
And it's not a software bug. It's not some purely algorithmic problem.
No, it's a fundamental human bias. And here's the best part. There is a simple, completely training-free prompting fix that can immediately restore the model's true, diverse potential.
It's a really data-centric view on a huge AI challenge.
Yeah.
For years, people blamed mode collapse on, flawed reward models or weird sampling techniques.
Right, the complex stuff.
But this work, it shifts the blame upstream. It points right at the human preference data that we use for alignment.
Exactly. We used to think the optimization pipeline was broken, but the source material says no, the problem is deeper. It's hardwired into how we as humans judge quality.
And they call it typicality bias.
Typicality bias, what is that?
It's our inherent subconscious tendency to favor text that is familiar, conventional, or just easy for us to recall.
Yeah.
We are fundamentally wired to like things we already recognize.
That changes the whole diagnosis. You're saying basic cognitive psychology is influencing these multi-billion-dollar AI models.
It is. The researchers pointed to a few core cognitive effects.
Okay.
First, there's the mere exposure effect and the related availability heuristic.
So just because you've seen something before, you like it more.
You like it more, and it feels more correct, more representative of what a good answer should be. If a common phrase or joke structure keeps showing up, the human rater is just predisposed to favor it.
So familiarity doesn't breed contempt. It breeds higher reward scores.
Precisely. And the second thing is processing fluency.
Meaning how easy it is to understand.
Exactly. The cognitive ease. Text that is simple to read, to process, is automatically perceived as being higher quality.
So let's make that concrete. Say I ask for a short story. The model gives me one that's, brilliant but a little abstract, and another that's a simple once upon a time fairy tale.
The fairy tale wins.
Why?
Because the annotator, when faced with the abstract story, has to pause.
Yeah.
They have to think. It requires a higher cognitive load. And subconsciously, that friction gets translated into a lower quality score, even if the content is objectively more creative.
But is this just a theory, or did the researchers actually prove this bias exists in the data?
Oh, they proved it. They analyzed preference data sets, and they looked at pairs of responses to the same prompt. And crucially, they looked at pairs that had the exact same correctness rating. So they were tied on actual utility.
So 2 answers that both solved a math problem correctly, for example.
Yes, exactly. They were looking for the tiebreaker.
And what did typicality do in those moments?
The finding was stark. I mean, even when 2 responses were objectively tied, the one that was more typical, the one that was statistically more common, had 1.42 to 1.47 times higher odds of being judged as more helpful.
Wait, let's just pause on that number. 1.47 times higher odds.
Yes.
That means the preference data is actively selecting for boring, common answers nearly 50% more often, even when better, more novel answers are just as correct. That's enormous.
It is, because it explains the whole mechanism of collapse. This typicality bias, it acts as the tiebreaker during that RLHF optimization.
And in creative tasks, like writing a story or a joke, there's no single best answer.
Right, the true utility is flat across many good answers, so the model should be diverse.
But it isn't.
It isn't, because when the utility is flat, that typicality bias takes over. The model learns that the easiest way to get a high reward is to just aim for the most common, most typical answer it knows.
So it's not that the model can't generate the interesting answer.
Not at all. It's just learned that we humans won't reward them for it. The creativity is still there. It's just hidden.
Okay, so if the problem is this hardwired human bias in the data, how on earth do you fix it without retraining a model that costs millions of dollars?
And that's where the solution is just. It's remarkably elegant. It's called verbalized sampling, or VS.
Verbalized sampling, what does it involve?
It's a principled, training-free prompting strategy. The core idea is that instead of asking for a single instance like one joke, you explicitly prompt the model to verbalize a distribution of responses.
With probabilities.
With their corresponding probabilities, yes.
So you're forcing the model to switch roles. It's not a creative trying to guess what I want anymore.
Right.
It's now a statistician describing the whole landscape of possibilities.
That is a perfect analogy. So instead of, tell me a joke about coffee, the prompt becomes a meta-instruction. Something like, generate 5 responses with their corresponding probabilities. The question is, tell me a joke about coffee.
And what's fascinating is how that prompt change affects the mode collapse itself. How does asking for a distribution unlock the diversity that a direct question just locks away?
Well, that's the key insight. A traditional, what they call an instance-level prompt, makes the model collapse to that single stereotypical response we hate.
The mugged coffee joke.
The mugged coffee joke. But when you switch to a distribution-level prompt like VS, the model collapses to a mode that approximates the full diversity of its original pre-training data.
So it's like you're asking it to retrieve its original unbiased memory.
You're asking it to show you the whole map, not just the most popular tourist spot. And they showed quantitative proof of this.
Right, with the U.S. states example.
Exactly. Ask it directly to name a U.S. state, and you get California, Texas, New York over and over.
The usual suspects.
But with verbalized sampling, when they asked for a distribution of states, it produced a list with probabilities that almost perfectly matched the actual statistical frequency of state mentions in its original training data.
And how close was that alignment? Because that's the real proof.
It was incredibly close. For one model, they measured the statistical deviation, the KL divergence, and it was only 0.12.
For those of us not deep in stats, a KL divergence of 0 means a perfect match.
Yes. So 0.12 is just. It's an incredibly low score. It proves that VS successfully forced the model to reproduce the diverse, messy, wide statistical profile of its original data.
So the model still knows all the weird, atypical answers and how likely they are.
It just needed permission through the prompt to tell us about them.
Okay, that confirms the mechanism. The diversity is hidden and the prompt is the key. Now here's where it gets really interesting for me. Let's look at the real-world results. Where does this shine? Let's start with creative tasks.
Right. On things like poems, short stories, jokes, VS significantly boosted semantic diversity.
By how much?
By a huge margin. Across those tasks, the diversity increase was anywhere from 1.6 to 2.1 times higher than standard prompting.
A 2 times increase is... That's hard to visualize. The story generation example makes it really vivid.
Oh, absolutely. Ask a normal aligned model. Write a short story about a bear.
And you get the mode.
You get the mode, repetitive outputs about a grizzled old bear ambling through the morning mist. It's safe, familiar, and boring.
But with verbalized sampling...
You access completely different ideas.
Yeah.
You got stories like Bernard the Bear working as a tax accountant in downtown Seattle.
A tax accountant.
Or a story about a bear that wasn't even a physical animal, but the cosmic spirit of the constellation Ursa Major narrating the passage of time.
Yeah.
The model's real creative range was just unleashed.
And the crucial question, what about quality? Usually when you force diversity, the quality drops off a cliff.
Not here. Human evaluations show that VS either maintained or even slightly improved the average quality scores.
So diversity and quality aren't a zero-sum game here.
Not when you're correctly sampling what the model already knows. You're not adding noise.
Yeah.
You're just uncovering the hidden gems.
Did the researchers notice any other sort of emergent trends with this method?
Yes. A very significant scaling trend.
You mean?
Larger, more capable models benefit way more from VS. The big models saw diversity gains 1.5 to 2 times greater than the smaller ones.
Which suggests the biggest models have the most diversity, but it's also the most suppressed by alignment.
Exactly. The alignment has to work harder to squash all that potential down into one safe box.
And you mentioned this also gives developers a new way to tune the model's output.
A huge practical benefit.
Hmm.
Because the model's giving you explicit probabilities. You can tune diversity just by changing the prompt. You could just say, generate 5 responses, but only give me options that fall below a 10% probability threshold.
Wow. So you're literally telling it, ignore the common stuff. I only want the interesting, low probability ideas from the tails of your distribution. That's a developer's dream.
It completely gets rid of fiddling with complex decoding parameters like temperature and top P. You just use plain language.
Okay, let's pivot from creative writing to something more technical. Dialogue simulation. How does this help an AI simulate human interaction?
Well, real human dialogue isn't predictable, especially in persuasion. Direct prompting produces dialogue that's too logical, too compliant.
It gives the perfect answer, not the realistic one.
Exactly. On persuasion tasks, VS enabled models to simulate human behavior much more realistically.
Yeah.
For example, when simulating someone being asked to donate money, it generated donation amounts that were way closer to what real humans actually do.
It modeled that messy middle, not just a yes or no.
It did. And even more importantly, it simulated complex behaviors like resistance or someone actually changing their mind during the conversation. That's critical for any kind of high-fidelity social simulation.
Finally, let's talk about the ultimate feedback loop. Using these models to make the next generation of models better through synthetic data.
Right. The quality and diversity of your synthetic data directly impacts the performance of the model you train on it. If your data is mode collapsed, your new model will be too.
So what happened when they used VS to generate synthetic math problems?
The resulting data was just fundamentally more diverse. And the models fine-tuned on that VS-generated data achieved an average accuracy of 37.5% on math benchmarks.
And the models trained on the standard directly prompted data.
They only got 30.6%.
That's a 7-point jump in math accuracy just from changing the prompt used to make the training data. That's huge. Why?
It wasn't just about generating more diverse correct problems. It's that VS also generated diverse and compelling incorrect solutions.
Negative data.
Exactly. Teaching an AI all the clever ways humans can get something wrong is vital for building robust understanding, not just pattern matching.
And throughout all of this, creative, social, technical, the core reliability of the model was maintained.
That's the most empowering finding, really. The sources confirm that VS maintained factual accuracy and safety standards. It proves the mode collapse was just a behavioral filter hiding the model's true inherent capacity.
So to summarize our deep dive, the problem of LLM repetition mode collapse, it's not really an algorithmic flaw. It's rooted in a fundamental human cognitive error, typicality bias, our subconscious preference for the familiar.
And the fix is brilliantly simple: verbalized sampling, a prompting technique that just asks the model to reveal its underlying probability distribution.
And in doing so, it instantly unlocks the full generative diversity that was already there, hiding inside the base model.
It's a powerful, practical, lightweight solution that works right at the inference stage. It proves these aligned models are still incredibly creative. We just needed to learn the right way to ask.
And this leads us to our final provocative thought for you to consider. Since verbalized sampling lets a model articulate its full distribution of possibilities, even the rare ones, how might you apply this to encourage creative exploration in, say, reinforcement learning? If an AI agent can use VS to discover high-reward behaviors that were previously too atypical to even be considered, this could completely redefine how AI innovates, from robotics all the way to fundamental scientific discovery.
A fascinating path forward.
We've covered a ton of essential material today. We really encourage you to dig into the source material yourself to see these results. That's it for this deep dive.